Look at this crazy shape. You start at the point A, and you gotta end up at the point B. But you can only move along the black lines. No teleporting. Okay? And actually, in fact, you can only go in two directions. Two directions. You can only go down, or you can go to the right. But you can't go up or left. Only down or right. Okay? Those are the rules. Okay. But don't worry, it's still easy. There's loads of ways to do this. Here's one way, here's another way, here's another way, here's another, and another. There are many, many, many ways. But how many? How many different ways are there? That seems like a really, really hard problem. But actually, it's not. Actually, it's really easy, once you know the trick. Of course, there's a trick. What's the trick? I'll show you. But first, let's try a simpler version of this problem. This big, hideous, crazy shape, it's too complicated. What if we just started with a nice and simple 4x4 square grid, like this? How many different ways are there to get from A to B on this grid? Okay, well, look at the point B. If we want to get to B, there are many ways, but in the last step, we will have to go through one of these 2 points. Either we travel to this red one, and then drop down to B, or we travel to the blue one and go to the right, to B. Those are the only 2 black lines that connect to B, so obviously there's no other way to get to B. And what that means is, the total ways to get to B must be exactly the sum of the ways to get to these 2 separate points. Let me explain. Let's say, for example, there's 7 ways to go from A to the red point. I don't know if there's actually 7, but let's just say it is 7. Don't worry, we can change it later if it's not. Okay, so 7 ways. And let's say the blue point has 8 ways to get to it from A. Just bear with me. Now, if both of those things are true, then it means B must have exactly 15 ways to get to it from A. 15, okay? 7 plus 8. It has to be, because there are no other ways to get to B. Okay, so the ways to get to B is exactly the number of ways to get to the red point above it, plus the number of ways to get to the blue point on the left of it. Okay, but now here's the trick. Ready? This doesn't just only apply to B. It actually applies to every single point in the entire grid. Look, we can pick any random point. I don't know, say this purple one. Now I have no idea how many ways there are to get to this point from A. But it's got to be exactly the sum of the ways to get to the red one, plus the number of ways to get to the blue one. By the way, quick side note, this would not be true if we could go in all 4 directions. If we could go up or down, and left or right, then it doesn't work. It just breaks everything. For example, we could take this path. This would be a perfectly valid path, but this path does not go through either the red or the blue point. It goes around them and loops back. Things get way, way, way more complicated if we're allowed to go in all 4 directions. But that's for another time. Right now, we can only go down or right. So yeah, I mean, you can try to go around the red and blue points, but then you'll never be able to get back to the purple one. Not without going upwards or left at some point. That's why every path that ends at purple must go through either red or blue. Alright, and now we've got everything we need to solve this 4x4 grid case. So we'll start with this point next to A. How many ways are there to get to here from A? Well, that's easy. There's only one way, this one. So I'm going to write 1 here, right next to the point, just so we can keep track. Okay, now we jump to this point underneath A. How many ways are there to get to here from A? Again, there's only 1. So like before, I write 1 next to this one too. Okay, but now, have a look at this point. How many ways are there to get to here from A? Well, this is where we can use our new trick. The number of ways to get to this point is exactly the sum of the ways to get to the red and blue points. But we just figured out the ways to the red and blue points just before. Both of them have only 1 way. 1 way each. So 1 plus 1, that's 2 ways. So there's 2 ways to get from A to this purple point. And so this time, I write 2 next to the point. Righto, and we carry on with the same idea. and we find these 2 points also have a value of 1. In fact, it's pretty obvious to see that all the points on the edges will have a value of 1. But now look inside and things start to get more interesting. This is our next point. How many ways are there to get to it from A? Well, the red point above it has a value of 2, and the blue point to the left has a value of 1. 2 plus 1 is 3, so this point has 3 ways to get to it from A. Okay. First 1, then 2, now 3. And you know what, just to be sure, let's check it. Here is the first way. Okay, and here is the second way. Yep, and this is the third way. Those are the 3 ways to get from A to this point. And yeah, it doesn't look like there's any others. It works! And now we just keep going, 1 point at a time. And slowly the numbers start getting bigger. And bigger. And now they're getting bigger a lot faster as well. Up to 20 already. Now 35. Almost done. There we go. Finally we reach B itself. And for B, we get a value of 70. 70, okay. And that's the answer. 70 is the number of different ways to get from A to B on this 4x4 grid. Nice. Alright, that was slightly amusing, but hold on to your socks, because that's just the beginning. This method of going through each point one by one, it's actually extremely powerful. Way more powerful than you'd think. It doesn't just work only for squares. Oh no. We can do it on just about any shape. Here, let's try this funny looking L shape. How many ways to go from A to B on this? No worries, bro. We do exactly the same thing. First, it's obvious all the points on these 2 edges have only 1 way to get to them from A. Either straight down or straight across. Easy. So, let's just number them off straight away. Might as well. And then we go around numbering the points inside, starting with the points closest to A and slowly working our way towards B. 1 by 1, the points all get numbered. Okay, yes, it does take a while, but it'll get there eventually. And yes, we could skip the whole thing using Pascal's triangle, but, I don't want to. I like watching it. It took a lot of effort to hand make every one of these individual frames, so I'm going to savor every single one. And besides, Pascal's triangle won't work for the next thing we're going to do. Nearly done, and the final answer is 301. 301 different ways to go from A to B on this L-shaped grid thing. Okay, but it gets better. We can still do more. We can even have holes inside the shape. Still works. The only annoying part with holes, though, is you gotta be a little more careful. You can't just add the red point and the blue point every time anymore. Now you also have to check that both of them are actually connected to the purple point. Because if one of them isn't connected, then obviously you can't get to the purple point from it. And in that case, you don't add them, you just copy the value of the point that is connected. You just copy it. Or if neither point is connected, then you just write 0. Boring, trivial stuff, no one cares. Okay, ready? 1, 2, 3, go! Haha, it's doing it. Okay, but it's too slow. We're gonna be here all day, speed it up, double time. Yeah. Actually, the holes kind of make it easier in a way. Thank God for these holes, or else these numbers would be getting insanely big. I mean, we're already in the hundreds, and very soon we'll reach the thousands. But if there were no holes, oh geez, it would get to the tens of billions. And I'm not exaggerating either. 40 choose 25, that's over 40 billion. Crazy. And I had to add up all these numbers, I didn't write any code to do this for me. The only thing I can do in Python is a for loop. Look, I don't code, okay? Only thing I know is adding numbers. That's what I do. You got 2 numbers? I can add them for you. And it's finished! Finally! But I can't see, it's too small. Magnify! Yeah. Wow, would you look at that? A whopping 243,784 ways, different ways, to get from A to B. Jesus Christ, that is a lot of ways. Okay, now you know. Please subscribe to my channel. Bye.